Hello and welcome back. This is Zero with Dot here, and today I'd like to talk about three very important technical skills that I think make some people really great engineers, and these skills are also completely transferable between different technology domains. And why am I saying this? Well, as you can see, technology is something that changes really fast, right? If you're working with technology, regardless of your role, regardless of the discipline, you probably see how quickly things change. So chances are that in less than a decade, your role might be gone, might be replaced with something else, and you'll be forced to unlearn something and relearn and requalify, basically. So it happened to me twice already. I started off in photonics. I was working with sensor designs, working in the lab. Then I moved on to embedded software development, which was about something completely different, even though that I worked with the hardware. Now I work as a data scientist for an e-commerce business. So these things apparently seem to be completely unrelated. But as I look back, I see that they're actually a part of the same picture. And whenever I was thinking about my own skills, or especially the skills about people, of the people who I really admire, some people who are really good at what they were doing, it basically boils down to three skills that I think are the key points. So let me present them to you. The first skill that I noticed that is of value is mathematics. And don't get me wrong, I can imagine you saying, it's like, oh, I don't have to know calculus to get my job done, or I mean, I had linear algebra back at school, I don't really need to know, I mean, there's a Python package to solve that for me. Well, if you're thinking along these lines, then I don't really have a good news for you, because you need to know what works behind, and there is probably no such other field that teaches you how to do domain modeling than mathematics. And mathematics is a particular field because it is not attached to any particular domain. It is completely abstract. And domain modeling is a part of an engineering job. I mean, unless you're able to create that mental representation or a symbolic representation of your problem, then you don't really know what to solve. And mathematics is something that helps to understand how things can get formulated. To me, mathematics is not about equation solving as much as it is about equation writing. So people that are really good at what they're doing, I have observed, were always very good at mathematics. They knew, they could imagine what sits behind, how these things work. They basically had a highly developed sense of abstract thinking, and that's also what got them really creative. So I think mathematics is the skill number one. The skill number two is what my friend calls following an error. And, you know, a part of engineering job is fixing things. And constantly, you probably have to fix things every day. And people who are really, really good at fixing things, these are the people who have the ability to resolve the technology at different levels. And they see the technology, the different pieces, as a part of the same building. It has to do with analytical skills, but it's not like, you know, in the job description, like, we need a candidate with good analytical skills. And it's like, yeah, but it's not like analytical skills like for using Excel. It's analytical skills together with debugging. It's the ability to decompose a bigger problem into smaller ones and attack them at different levels. And that's also what really gets these people very efficient, is that they don't care if the problem is at the attic or is it at the basement, you know, if it's problem with deployment or is it a problem with the application or is it a hardware problem, should I, you know, remove my keyboard and bring a soldering gun, you know. They just do their work. And the last skill is somewhat similar to analysis, but it goes the opposite way, and that's synthesis. And that's especially important when you design system. So maybe you're not in the architecture role, but one day you will. But even now, like when we solve problems, then oftentimes we just want to see what pieces we can use to make that building. And it's oftentimes not about the pieces themselves, as much it is about finding interfaces, how potential pieces can come together. So when you're building things, designing of the interfaces are very important, because things also happen in teams. So very rarely you will find a person who is, you know, omnipresent, you know, knows all technologies across. I don't think these people exist. So people have to collaborate, and when they collaborate, when engineers collaborate, they communicate through interfaces. So whoever has that ability to imagine a complete project, a complete solution as a part of the different pieces and can define those interfaces very efficiently is going to have the advantage. And these three things I've seen are applicable regardless of the technology. It's a trait, you know, it's in hardware design, it's in software design, it's in data science, it's in modeling, and so on. So these are the three skills that I think are of value. And so even if you're working precisely like with one technology, let's say NLP problems or image recognition, or you're a web developer, I would encourage you, and myself included, to exercise on those three things, because one day maybe all NLP problems will be solved by some super cool AI. And then the future of your career or my career will depend on our ability to learn new things and requalify. And the better we become at these three things, then I think the easier our life will be. So that's it for today. Thank you for watching this video. If you liked it, then please give it a like or subscribe. I also have a mailing list. Visit my blog, and see you next time.